Recording. Question 7. Chris is running marathons. Good, well done, Chris. And he's following a training program to improve his times. First marathon is 150 minutes. First half marathon. His time for the second is 147. He believes that his times can be modelled by a geometric progression. Of course they can. Chris sets himself a target of completing a half marathon in less than 120 minutes. Show that this model predicts that he'll achieve his target on his 13th half marathon. Okay, I would prefer to do this question as being, I don't know that it's the 13th. I'm going to show that n equals 13 and do it that way. Although you could just test out some numbers and show that it works with particular numbers. But what we're saying is a geometric progression. That's right, isn't it? So the first term is 150. He believes there is a common ratio, and the common ratio is 147 over 150. That's 0.98, isn't it? So we want the first one that is less than 120 minutes. That's what we're after. So we want 150 times r to the n minus 1 to be less than 120, and we're looking for the first value of n that satisfies that equation. This is not the method that's in the mark scheme, but this is how I would do it, because I'd want to set it up that way, I think. So we do 120 divided by 150, I don't know why I'm doing it on a calculator, it's a bit embarrassing, is 4/5. We're going to take logs of both sides. n minus 1 times ln 0.98 is less than ln 0.8. We're going to divide by 0.98. 0.98 is less than 1, isn't it? It's less than 0 even. Natural log of 0.98 is negative. There it is. So when we divide by that, we're going to change the sign of our inequality. So n is greater than ln 0.8 over ln 0.98 plus 1. Go to the calculator. ln 0.8 over ln 0.98, I didn't close that bracket, I don't know if it matters, plus 1 gives me 12.045. N has to be an integer, it has to be greater than 12.045, therefore as n is an integer, n must be 13. I have not got all the marks, because this is a question that is all about context, so we have to put our answer back into context, and they really wanted you to say, therefore, the 13th half marathon. I think that is a bit fussy, but if you don't include a reference to it being 13 half marathons, or 13 runs, or 13 marathons, you could get away with even saying that. If you don't actually put it into context, you don't get the final mark. It's really harsh, isn't it? But that's how it was. Part 2. After 12 months, Chris has spent a total of 2,974 minutes to the nearest minute running half marathons. Brill. Use this model to find out how many half marathons he's run. So that's the sum, isn't it? That's saying that the sum of his n marathons is equal to, or approximately equal to 2,974. So that is, the sum is A times 1 minus R to the n over 1 minus R. So we're going to do 150 times 1 minus 0.98 to the n over 1 minus 0.98. Can you guess what's happening in the final mark of this already? Based on what we just said, you're going to have to refer to marathons again. If we simplify this, we want to get n. So we're going to do, how should we do this? 150 divided by 0.02 is 7,500. So 1 minus 0.98 to the n is 2974 over 7500. Rearrange that and I get 0.98 to the n is 1 minus that. 1 minus 2974 over 7500. So that is going to be 1 minus 2974 over 7500. 0.6 something. I'm going to write it as a fraction. 2263 over 3750. So we're going to take logs of both sides. So n ln 0.98 is that fraction. Oh, n is ln that fraction. So n is equal to that divided by, oh, it's gone again. What are we doing? Natural log of my answer divided by natural log of 0.98. And we get 24.9998. 25. So 25 marathons. Half marathons. Again, I think it's a little bit fussy, but they demanded that you put it into context, saying n equals 25 was not enough to get the mark. It's horrible, isn't it? Anyway, there you go. If the question has a context, make sure you put your answer back into context. Give 2 reasons why this model may not be appropriate when predicting the time for a half marathon. It's got to be about context as we give our answer to this. So, and it's got to be sensible as well, our answer. So, actually, yes, as n tends to infinity, this would tend to 0. But I don't think it's a sensible criticism of the model to say if he ran an infinite number of marathons, he'd be doing them in 0 time. I'm not sure that's a fair criticism, because we're never going to get, realistically, this is somebody who's running half marathons. He's never going to run an infinite number of half marathons, is he? So I don't think that's a reasonable criticism. It is a criticism to say that this is assuming that his times will always improve, whereas actually he probably will reach some point where it becomes increasingly difficult to improve his times. So a fair criticism is to say that it assumes that the times will always improve. Okay. A few of you said things like it assumes that the rate of improvement is constant. And I think that's a difficult one to define, because the amount of time that he's getting faster isn't a constant, is it? The amount of time he's getting faster is reducing every time he does it, because it's proportional to the previous ones. I think you have to be a little bit careful about how you phrased that. The other criticism I think a lot of you picked up on, and is a really fair one for the model, so think wider than just the mathematics of it. He's running half marathons. Presumably they're in different places in the country at different times of year. There are different conditions. So it doesn't take into account variations in the conditions or injuries or the weather or that kind of thing. It doesn't account for variations in conditions, weather, injuries, that any of those kind of things, different places where he's running, that kind of thing, terrain. Is that all right? There are a few marks there where it was borderline whether I gave it or not for some of what you'd written. So, there's maybe a little bit of room for arguing about some of those. Okay, any questions? Great.